everyone and welcome to this video. Today we will talk about chemical properties of group 2. So we talked about the physical properties of group 2 alkaline earth metals, and we saw that the atomic radius increases down the group. The two valence electrons in s orbital, the distance between those two valence electrons and the positive nucleus increases going down the group. This is why the attraction will decrease, and this will make it easier for group 2 to lose their two electrons, valence electrons, which means the reactivity would increase going down the group. So the distance, the atomic radius increases, the reactivity also increases, because you are decreasing the attraction between the valence electrons and the nucleus. Now, if we looked at group 2 reaction with oxygen in here, if we ignite magnesium ribbon in presence of oxygen air using benzene flame, you could see that white fumes are formed. If you looked at the reaction of magnesium ribbon in presence of oxygen, magnesium reacts with oxygen in air to give me magnesium oxide. Magnesium oxide has a basic character because when it dissolves in water, it gives me magnesium hydroxide. In here you could see this milky color of the water due to the formation of magnesium hydroxide, which has a basic character and slightly soluble in water. So we use the flame test to distinguish between the different metals of group 2 elements, and you could see here the calcium usually ignite, forming a brick color, a brick red color. In case of strontium, it forms a scarlet red, barium forms apple green, and of course magnesium we have seen before that it forms a white color. Now moving to calcium reacts more readily than magnesium or beryllium. Actually, it reacts with water at room temperature, and it gives me calcium hydroxide. And this calcium hydroxide also you have hydrogen evolves, and for barium it reacts vigorously in presence of water, releasing hydrogen gas and barium hydroxide. So if we looked at the alkalinity of group 2 elements, it increases going down the group. And the reason behind that, you are increasing the solubility. So you are moving from minus 10 to the fifth power to the minus 3, then you have minus 2. So you are increasing the solubility. This is why you are increasing the alkalinity as well. The more soluble means more dissociation. This is why you will have a more alkaline solution. Now, if we looked at the solubility of group 2 sulfates, it actually decreases going down the group. So you have the solubility of hydroxides increases going down the group, but in here the solubility of sulfates would decrease going down the group. And the reason behind that is the enthalpy change of hydration. So you have the positive cation surrounded by water molecules and the negative anion surrounded by water molecules, and this hydration, when it happens, if you have a larger atomic radius, the attraction between the positive cation and water molecules would decrease, similar to the negative anion with the water molecules. So you are increasing the atomic radius. This is why your hydration, enthalpy change of hydration would decrease, because you are decreasing the attraction between the ions and water molecules. Now, if we looked at another reason, also the lattice energy would decrease going down the group. So you have the lattice energy decreases, this energy that you require to stick the ions together, decreases going down the group. This is because it is inversely proportional to the sum of anion and the cation. So you are increasing the atomic radius, you expect the lattice energy would decrease, and you have this less exothermic reactions of when you dissolve sulfates going down the group. So the solubility of sulfates decreases going down the group due to the enthalpy change of hydration decreases, and the lattice energy decreases as well. Now, if you look at group 2 carbonates, They don't react with water. They don't dissolve in water except for beryllium. They react with dilute acids. In here, if you see magnesium sulfate, magnesium carbonate, when it reacts with dilute sulfuric acid, it gives magnesium sulfate, water, and carbon dioxide. Now, except for this reaction, the rest of elements, when the example for that, when calcium carbonate reacts with sulfuric acid, dilute sulfuric acid, what happens is actually the formation of the insoluble sulfates that would just deposit on the carbonate, preventing the further reaction of the carbonate with the dilute acid. Now moving to the reaction of group 2 elements with dilute nitric acid, they form the soluble nitrate salts. In here I have calcium carbonate. When it reacts with dilute nitric acid, it gives calcium nitrate, water, and carbon dioxide. Also hydrochloric acid reaction, dilute hydrochloric acid reaction with in here I have barium carbonate, any of group 2 elements carbonates. They react forming the chlorides of group 2 and those chlorides are soluble, and in here you could see barium chloride is formed, water and carbon dioxide. Now moving to the reaction of carbonates with dilute nitric acid, they form soluble nitrate salts. In here I have calcium carbonate. When it reacts with dilute nitric acid, it gives me calcium nitrate, water and carbon dioxide. In here the calcium carbonate is soluble. Now moving to the reaction of carbonates with dilute hydrochloric acid, they actually form soluble chlorides, chloride salts. In here you have barium carbonate. When it reacts with dilute hydrochloric acid, it gives barium chloride, which is soluble, water and carbon dioxide. Now moving to the thermal decomposition of group 2 carbonates and nitrates, they decompose at high temperature, giving off metal oxides. These metal oxides, in case of carbonates, it gives off metal oxide and the carbon dioxide. But in case of the decomposition of nitrates, it gives off the metal oxide and the toxic nitrogen dioxide gas, which have a brownish color. Now moving to the temperature at which thermal decomposition happens, it increases going down group 2. For carbonates, you are decreasing the polarization. This is why you are increasing the thermal stability of carbonates. If you looked at magnesium in here, it polarizes the carbonate and weaken the bond between the carbon and oxygen. This is why the decomposition happens at lower temperature than in case of calcium, which has a larger radius and it doesn't polarize carbonate. This is why the decomposition happens at higher temperature. So going down the group, you are increasing the radius and you are decreasing the polarization, where you are increasing also the stability. This is why the thermal decomposition takes place at higher temperature. Now, if we looked at nitrates, the stability of nitrates going down the group actually increases. So you have the barium, which have a higher stability, has a higher stability than strontium. Calcium moving to magnesium would have the less stability. So the more stable, the higher the decomposition temperature would be. Moving to the uses of group 2 compounds, and for calcium, it is found in limestone, which is a form of calcium, is the calcium carbonate. There are many types of limestone that provide useful rocks for buildings. Now, marble also is another form of calcium carbonate that is used in building material such as tiles. Calcium carbonate or the limestone is also used to make cement. So the first step usually is roasting the limestone in lime kiln at high temperature. Now, when the calcium carbonate decomposes, it forms calcium oxide, which is a quick lime that is further roasted and mixed with clay to make cement. When the cement is mixed with sand and small pieces of rocks, it makes the concrete that we use in buildings. Another famous compound of calcium is the slacked lime, which is the calcium hydroxide that is used to raise the pHs of acidic soil, because calcium hydroxide has a basic character that reacts with acids in the soil and neutralizes them, raising the pH of the soil. For magnesium, it is a soft, light material. And easily burned. This is why it is used with a brilliant light in the photographic flash bulbs. Also, magnesium sulfate, which is Epsom salt, is used to relieve pain and muscle cramp. Group 2 salts are also used in fireworks. For barium, it is used to create this green color in fireworks, and it also can help to stabilize other volatile elements. For calcium, it deepens the firework colors, and calcium salts produce orange fireworks. Magnesium burns with a very bright white color. This is why it is added to add these white sparks and improve the overall brilliance of the fireworks. Strontium salts impart a red color to the fireworks. Also, strontium compounds are also important to stabilize fireworks mixture. By that, we came to the end of Group 2 chemical reactivity. Until next video, thank you and goodbye.